Hello everyone. In this video we are going to prove the following two formulas, which is sine x plus sine 2x plus dot 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 until sine nx, and also the cosine version. And we will use very basic elementary geometry to prove them. There are three most common approaches to prove the above formula. The first one is the telescoping with the product to some trigonometric formula. And we usually will multiply the whole series by sine x over 2. And there are lots of videos on the internet, so you can watch them for reference. And the second one is using the Euler's formula in the complex number. And then we compare the real and imaginary part with the geometric series. And then the third one is the mathematical induction. So let's start with the unit circle first. And we will try to locate several lines on the unit circle. And the first one is we mark the angle x here, and then this point, because the radius of the unit circle is always 1, so the point here we can draw a right triangle here, and then because the hypotenuse is 1, so the horizontal distance here is cosine x, and the vertical distance is sine x. So the first point, the coordinates is cosine x, sine x, and then we will mark another point with the angle, this bigger angle, 2x. So this point, it will have the coordinates cosine 2x, sine 2x, and then we will continue this process to mark each angle x, 2x, sine 3x, and 4x, and so on. So now we will move each line to form the side of a regular n-sided polygon like this. So if we consider the vertex of this n-sided polygon, we will get the coordinates of each point like this. And the first point here, is coordinates is cosine x, sine x. For the second point, because after you have moved a horizontal distance of cosine x, you move by a further cosine 2x to reach the second point. So the x coordinate is the sum of cosine x and cosine 2x. And the same for the vertical distance, sine x plus sine 2x. So if we continue this process until we reach the nth point, so the coordinates of this nth point is the sum of cosine x, cosine 2x until cosine nx, and the same for the y coordinate. So now we'll draw a right angle triangle from the nth point to the x-axis, and then we connect the nth point with the origin, and then we will focus to find angle AOB, which is this angle, and the length of OA, which is here. So we'll find OA first. So we'll focus on each small triangular fragment here, and let me zoom in. We know that this angle is x, and then each triangular fragment is an isosceles triangle. So these two base angles are the same. So we can calculate the base angle of each triangular fragment, which is 180 degree minus x over 2. So this is 90 minus x over 2. And then for the vertical angle, we can use the sum of a triangle, 180 degree minus 2 times 90 minus x over 2 bracket. And then we multiply the 2 inside, we'll get a simple answer, x. So now we can use sine to find OC. So where's OC? OC is this length. So now I will divide this triangular fragment into two equal parts. I will draw the middle line here, and this is the right angle triangle, and this part is OC, and the bottom part, this is equal to 0.5, 1/2. So now we have the angle here, which is x over 2, half x. So now we can use sine x over 2 is equal to 0.5 over OC. So we will multiply OC to the left hand side, and then 0.5, which is 1/2, and then I will over the sine angle, this is OC, to the right hand side. This is 1 over 2 times sine x over 2. So this is the length of OC. And because there are n pieces of these triangular fragments, so we know that the total angle here will be n times x. So we can now mark our angle OCA, which is nx. And then we can use the sine again, because we can consider the big isosceles triangle here, OCA. So now we have an isosceles triangle with the side length both are OC, and then the middle angle is nx. So we divide the vertical angle into half. So now we can use the sine to calculate OA. So now we can write sine nx over 2, which is equal to half OA over OC, which is 1 over 2 times sine x over 2. So we'll simplify this expression a little bit. So we can write half OA multiply 2 times sine x over 2. So these two will be cancelled. So we know that OA is indeed equal to sine nx over 2 over sine x over 2. So now we are going to find angle AOB. And first of all, we know that this big angle OCA is equal to nx. So I write it down on the right hand side. Angle OCA equals nx. So we can immediately calculate angle COA, which is 180 degrees minus nx over 2, which is 90 degrees minus nx over 2. And we know that this angle CO dot is equal to 90 degrees minus x over 2 we calculated before. So now we can calculate angle AO dot, which is here. It is equal to 90 degrees minus x over 2 minus 90 degrees minus nx over 2. So we remove the bracket, the 90 will cancel, and then we have nx over 2 minus x over 2. So now we can finally find angle AO boy, which is simply plus x behind. So we have n plus 1 bracket over 2 times x. So now as a final step, we gather all the information in a single right angle triangle. So now we can use sine bracket n plus 1 over 2x, which is equal to its opposite, which is a summation of k equals 1 to n sine kx over the hypotenuse, which is sine nx over 2 over sine x over 2. So we can multiply the whole denominator to the left hand side. So we get the formula for the summation of sine multiple angle x, which is equal to sine n plus 1 over 2x times sine nx over 2 over sine x over 2. And for the cosine part, it is very similar. So we write cosine n plus 1 over 2x, which is equal to the summation of cosine kx over the same denominator, sine nx over 2 over sine x over 2. So now finally we get another formula for cosine kx, which is equal to cosine n plus 1 over 2x times sine nx over 2 over sine x over 2. And I hope you guys will enjoy this video, and thank you very much for your watching, and I'll see you in the next video. Bye bye.